So Jiva, I'm feeling really good about this section because we're beginning to deliver on promises, because back in the section where we were looking at declaring our classes, we sort of skipped over a whole bunch of syntax on these things called properties, and we said we'll come back later. Well, we've come back. Mm-hmm. We're good to our word. So properties, what are they? What are we doing with them? What did all that syntax mean?
Okay. Well, properties are a relatively recent addition to Objective-C. They, again, were introduced with Objective-C 2.0. And essentially, properties allow you to declaratively define access methods for the data members of your classes. So
okay, let me that's straight with a question. Mm-hmm. So the data members of our classes are not just available by default. We have to provide access to them in some way, do we?
Correct. I mean, obviously, normally you would write setters and getters to access those data members. I guess, one thing that we want to make sure that's clear is what is a data member, right? And the data members are all of those attributes, all those variables that are part of your member variables, basically. So normally you would write setters and getters to access those
just
member variables.
Methods.
Yes.
Will either give you the value or set the value of that.
Right. They're known as accessor methods.
Okay. Right.
And so for example, you would write a set, in this particular case with this employee class that we have here, you might write an accessor method called setFirstName to set the first name member variable. Alternatively, you might write another accessor method that is for getting the first name variable. You might call it first name, for example, and that would return whatever's in the first name member.
So you'd be writing a code to give the person who is using your object access to the internal data of the object.
Right.
But I guess at the same time that protects the internal data of the object because you can do validation and all that sort of stuff when it's being sent.
That's part of the process of encapsulation. By hiding it behind accessor methods, you're encapsulating that data. And it's generally considered to be a good programming, object-oriented programming practice.
However, I mean, just looking at our employee class we have here with 1, 2, 3, 4, 5, 6, 7 methods, that's 14 methods we'd be writing that probably looked all fairly similar and the same.
It winds up being a ton of boilerplate code. And we hate, just writing the same code all the time. So that's why they gave us this property syntax. And using this, essentially all you have to do to get that same functionality is you can declaratively say, I declare that I have a property that is called first name, as shown with the highlighted line here, that is of type NSString, right? It's
which is the same pointer. Type as the data we're going to be setting.
The data that we're actually making this property for. And then we also have these, so you've got the name here, you've got the type here, and then we've also got these property attributes here, which you can use to tell the compiler what kind of accessor you want to have generated for you. And it'll take this and it'll do exactly that. It will actually generate that boilerplate code for you. You don't actually see it in your source code files because it doesn't generate it until it actually goes to compile the code. But it's there just the same, and so you'll have access to them.
So this isn't one of those awful code generators that just pumps out boilerplate code and then it goes wrong for the rest of its days. This happens when we build our project.
Exactly.
Okay.
So in this particular case, right, we've declared properties. Well, I should also point out that the syntax for declaring a property, of course, is again using this @ symbol and then @property, then the property attributes, then the type and the name. There's also another part to this, which is in the implementation file. You have to, in the implementation file, you also have to add this @synthesize keyword, which will actually cause that accessor to actually get generated. Now, there's actually two forms of this. There's the @synthesize that will actually generate the accessor for you. But in cases where you want to expose a property using the declarative syntax, but you still want to write your own accessor for it, you can also use the @dynamic keyword, which works with the @property declaration. In other words, you're still declaring I have an age property. But like in this particular case, right, the employee's age doesn't actually have a member variable because it's a calculated value. So
Right.
we wouldn't just be generating a synthesized accessor for that. We actually want to calculate that using the employee's birth date. So in that case, right, we actually have the age property specified here, and we're actually using the read-only attribute so that we wouldn't have a setter associated with that. We only have a getter associated
All right,
with
so
that.
the user of our object couldn't set this property, they could only read
Correct.
this property.
Correct. And then in our implementation, we actually specify that this is a dynamic property, which means we are actually going to create the accessor for it. Now, if we create this, if we say that it's dynamic, we still have to fulfill the same contract that we've specified in the property syntax. So in other words, if it was not read-only, we would have to provide both a setter and a getter. But since this one's only read-only, we only have to provide a getter. And so that's exactly what we're doing right down here. We've actually created a getter for the age property that simply calculates the employee's birth date dynamically. So that's an example of using a dynamic property. But generally speaking, usually most of the time you're going to be winding up using synthesize is probably the most common type of property that you're, or type of generated properties that you're going to wind up using here.
So we're declaring them in the header file,
Right.
and I'm guessing that declaration is going to get replaced by the compiler with the method declarations.
Yes.
And in the implementation file, we'll just put in the keyword synthesize, and the compiler is going to replace that with the actual implementation code that it's
Exactly.
going to generate on the fly.
Yes.
In whatever way it does it.
Yes. And now it's an interesting point that you should say in whatever way it does it. How it creates those accessors is determined by the attributes that we pass here. So in other words, like for example on this one, we've specified that this particular accessor, this particular property is non-atomic, and that it is a retaining property, which means that, we'll talk about memory management again, that's coming up next, but that means basically that that when the setter is generated, it will retain the value that's passed in versus copying it or assigning it. So there's a whole bunch of different attributes that can be specified as part of the property declaration. I have a table here that shows them, as a matter of fact. Essentially, it comes down to there's you can specify a getter name and a setter name, which it will actually use the name specified for the method names for the getters and the setters if you specify those.
Right, rather than the default names it's going to generate.
Exactly. And usually you would use that in cases where perhaps you've used unusual, or you're working with legacy code that has, maybe some programmers like to use what's called Hungarian notation, where they specify the type of their variable as part of their variable name. And maybe you don't necessarily want that as part of your getter. You don't want to say, or even part of your setter. You don't want to say something like set int first, or set string first name or something like that, right? You want to just say set first name. So in that case, you could specify that the setter's name is set first name, and it will use that for the setter as opposed to the automatically generated one that it would normally use.
So normally when we're declaring our property, does it have to, the name of the property has to match the name of the data that it's referring to?
Normally it does. It'll generate it'll generate the setters and getters based off of the property name. Well, it'll generate. Yes, it does. So,
Okay.
so yeah. But in the case that you don't want that to happen, right? That's how you would affect that. The next attribute there is whether you want it to be read-write or read-only. By default, it's read-write. That's the default value.
So if you don't put anything in, it will be read-write.
It'll be read-write. So in other words, that means it will generate both a setter and a getter. Mm-hmm. But if you want it to be read-only, like we did with that age property, then you would specify read-only. The next attribute is assign, retain, or copy, which again, I was talking about that retain, right? That's for the setter, and the idea is whether you want the value to just be assigned to the member variable, whether you want it to do a retain, which we'll talk about with when we talk about memory management, or whether you want it to be a copy setter. Generally speaking, I happen to prefer retain. Some developers prefer copy because they don't like having references to other objects, variables inside of them and things like that. Usually you will only use assign. Well, first of all, the default is assign. Usually you'll only want to really use assign when you're dealing with non-objects or when you're dealing with delegates, because delegates have to be assigned. They can't be retain or copy. That's part of the delegate contract.
We may have absolutely no idea what delegates are at the moment.
Well, we'll talk about delegates later.
That's good.
So I guess we're fulfilling some promises. We're making more promises.
As long as we fulfill them as fast as we make them, we're okay.
We'll get them. So again, that affects the setter. And then finally, there's this non-atomic property. The default is to be atomic. It can be atomic or non-atomic. This basically specifies, I hesitate to say the thread safety of the setter, because it's possible to be a little pedantic about that and say, well, I've specified non-atomic. Doesn't that mean that my object is thread safe? And no, it doesn't, right? Because what can happen is you can set a property and then you can go to set a different property, and the state might have changed in between those two based off of another thread accessing your object at the same time. So technically, it doesn't ensure thread safety for the entire object, but by specifying that a setter is atomic, you do specify that the setter itself is thread safe. In other words, that when you go to access the value using the getter, that you're ensured to always get a complete value, not one that's changed halfway through because
if two threads are trying to update that property at the same time, it will handle that and they'll queue up.
Exactly.
Now, you can't guarantee which ones just set it, but you'll have something decent in there, not something corrupt.
Right. Exactly. And so, generally speaking, you probably, for the purposes of writing good code, you probably want your setters, or you probably want your properties to be atomic, because that'll be thread safe. But if you are certain that your properties will not be accessed from multiple threads, then using the non-atomic property attribute can result in some pretty significant speed improvements when accessing your accessors.
And equally, there is no point in declaring your threads. There's no point in declaring your properties atomic if you're not going to bother to then write your methods in a thread-safe way.
That's correct.
Because you've just wasted your time.
Exactly.
And if you don't understand what we're on about thread-safe way, once you know Objective-C, you need to check out the concurrent programming course, which covers all this stuff.
Definitely.
That's the little plug. We have to get them in now and again.
So that's pretty much the gist of how you create properties. Now, one thing to kind of think about here is, so the next question is, how do you access properties, right? And so if we had these properties specified on an employee object, we can come back in here and take out our old code here. Let's say we had an employee object, and so we've created this employee. Now, once I've got this guy, I can actually do emp set first name and use that property accessor to just set that to whatever I want. So you basically use your properties by just using the accessor methods. There's also another syntax that you can use that was introduced with properties called dot syntax. So not only can you use these accessors like this, and just for the sake of completeness, let's see how we actually access that first name if we wanted to pull that out, right? Then we could also do emp first name, just like that. That's actually using the accessor to pull that guy out.
That's created a method called first name, which returns the first name,
right,
and a method called set first name, which will set that first name.
Exactly.
We just use them like any other method on our object.
Right. Those are using those properties. Now, if you wanted to use the dot notation, which also works with or which works with this. You could also do something like emp.firstname, just accessing that property straight away, and set that to whatever. And that will actually go through and use those accessors also.
So internally, that will be doing exactly the same thing as emp set first name.
Yes. And if you wanted to get that out, you could also do a string first name equals emp.firstname.
So am I correct in saying that technically and performance-wise and all of those other type of things that people will drag up, there is really no difference between these two methods?
Correct.
This is a matter of taste and style.
It is, absolutely.
And boy, do people have different tastes.
They really do. Yes. This is an object of great contention.
So if you're being taught how to do this by somebody and you really want to create lots of hot, fiery conversation for the rest of your developer career, just pick the opposite one to what they use.
Yeah, exactly. Now I'll say this, I really want to make sure that I point out something here, and that is, even though the dot notation here is calling the setter, okay, especially if you come from like C++ or Java, where dot notation is used for calling any method you want off of an object, that's not the case in Objective-C. Even though it might be possible to define a property that then allows you to affect or cause behavior to be executed on that object versus just setting a property, essentially affecting the state of the object, that is not considered to be good form.
No.
There are new developers to Objective-C who will sometimes say, oh, great, oh, cool, I've got this dot notation. That can make it so that I can write my code just like I wrote my C++ code. And I can say, emp.release or something like that, right?
No, anyone...
Don't do that.
Yeah. It doesn't matter which one of those you like, you're going to say, that's wrong.
Right.
That's very wrong.
Exactly. And, this was kind of drilled home to me in some discussions that I've had with Apple engineers, that the idea here is that the whole property syntax is really about state of your objects. It's not about behavior. And that you should really strive when you're designing your objects to encapsulate that state using properties, and that your behavior should only be exposed through methods, not through properties.
And I totally agree with that, because I know we have differing opinions on the dot syntax in a way.
I don't think so.
Well, I like dot syntax.
Oh, you do?
I do, there we are. But
Okay,
I like it because I use it properly.
Oh, all right.
I say in my own sort of humble way, because a property is about state.
Yes.
And therefore, I use the dot syntax as my way of setting state,
Yes.
and the method call syntax is my way of performing actions
Yes.
upon it. And to me, when I read my code, it gives a distinction between state setting and performing something,
Yes.
which I don't get if I do everything through the method calls. I've got no problem with doing the method call way. So now I agree with you. If I was to write 1,000 lines of code in my property setter, that would be a bad usage of it.
Very bad.
But that's not dot syntax's fault, because you could still do that with set first name if
Yes,
you really
you could.
want to.
You totally could. Yeah, absolutely.
So we can't blame dot syntax for that. That's bad use of properties.
Well-
but yeah, that's why I like it. But equally, it doesn't matter.
Yeah,
Whichever
yeah.
one you like.
Yeah, absolutely. That's true. I would say that in fact, actually, the point that I think the Apple engineer was trying to make was exactly that it's more of a justification that, use the properties for what their purpose is, which is exposing state, not behavior. And, one of the patterns that they suggested that you use is like this idea that, it might be tempting to, when you set a variable on your object, to also like have your setter, I'm going to persist this to disk when I do this setting. But that tends to lead to programming by side effect. In other words, the fact that I've set this property, it has the side effect of persisting that data to disk. And you don't really want to do that. What you want to do is you want to set your properties and then have a method that exposes the behavior of persisting it.
Exactly. So, for example, if I had a class that was doing something and I wanted to know if it was doing it, a timer or something, I wanted to know if it was running. There'd be several ways of going about it. You could have a running property which you could set to true or false to start it or stop it. But I think that would be bad. But you would have a start or stop method, but then you would have an is running property which was read only to give you the state of the property.
Yeah. See, we're in agreement.
Yeah, we are in agreement. We just use different syntax to achieve the same thing.
That's right.
Yeah, lots of developer love.
So that's properties in a nutshell right there.
Great. We fulfilled a promise, introduced some cool technology.
We have more promise fulfillment coming up.
Oh, and this is a big promise
This is a
fulfillment.
huge promise fulfillment.
Because we've been mentioning this one since, I don't know, it feels like eternity.
Yes, and it's a really important concept.
In case you haven't guessed, we're talking about memory management. Brace yourself.